CIT 1121, Module 9 and Submodule 9.1, Address Resolution. Let's get into what we were doing before, but to a little bit of a greater degree. And 9.1 talks about MACs and IP addresses. So if we go back and we think about our protocol data unit, once again, we got our PDU. I'm going to draw it again. Just keep drawing the same stuff over and over and over again. The first thing that a receiving device is going to read is a frame header. And inside of that frame header, there is going to be a source and a destination MAC address. Source and destination MAC. Next to that, the next header that gets added, or the header that actually gets added previously, because right about here it turns into a bunch of bits in electronic format. Over here we have a packet header, and that packet header is our global address, and it has a source and destination IP address. And in this chapter, we're going to talk about those source and destination IP addresses for IPv4 and an IPv6, and there is a special relationship between the MAC address and the IP address, and how we can use a known destination IP address to gain access to an unknown, like a mystery, an unknown destination MAC address, so we can leverage that through the magic of something called ARP, and we're going to do that in 9.2. But before we get to that, I'll just finish this off. We have the segment header here. Segment, and that is port values, ports, and then after that, everybody knows, you should be thinking in your head, the word is data. This is what's going to get processed by the receiving device. So, that being said, let's go ahead and move forward with our single slide in 9.1. And that is this slide here, where I've just taken parts of two slides and I pulled them apart. Now, here's the thing. Let's look at the top. If we look at the top first, what we've got is we have a frame header and a packet header for communication between PC1 and PC2. Now, if we look at the addressable structure, we'll see that the source MAC address for PC1 is all these A's, which it is right here, right? So that is that. And if we look at the IP address, the source IP address for PC1, we see that this says 192.168.10.10, and we have that IP address here. So that identifies the source. We have to tell the receiving device who sent the information, because most likely what's in the data section says, give me something, right? It's like, hey, I want some stuff. I'm looking to get an answer to this question that I'm asking you. And that's where that comes from. Now, in addition to knowing who you are, you knowing your MAC address that it was sent off of, which card, and the IP address of your device, you also got to know where you're going, right? Now, in most cases, you're going to learn the IP address of where you're going to go first. And the IP address of where you're going to go is going to be just the global address of what your destination is. In this case, we're just going across the switch. Everybody's in the same subnet. And inside of the destination MAC address field, we're going to see that it is the absolute exact value of the receiving device. So when we're sending stuff locally, we're going to use the actual information for each one of these devices. Now, here's the thing. When we get to the lower part of this, when we get to the bottom section, look at this. What are we doing here? We're sending some information from 10.10, 192.168.10.10, this guy here, and we are sending it to 10.1.1.10, which is this device that's over here, 10.1. Now, here's the thing. If we look at this source here, and this destination, we now see that they're on remote networks. And in the diagram, what they're trying to show you is that if we cross a router, we're going to go into another network. So this is actually 2 hops away. It's 2 networks away to get to that laptop over there. But we know the IP address of where we want to go. And in this case, instead of using the MAC address of the destination device, which would be loaded into the switch here, this switch has no idea what the MAC address is of this device. But what it does know is the MAC address of this interface right here, of the gateway. And your PC is smart enough to figure out that when it wants to send information to another device that's on the same LAN, it uses a protocol called ARP, and it says who is that particular device. And when it identifies that it wants to send information to another network, that the destination IP address is in a different network than the source network, then the destination MAC address that should be used will be the MAC address of the default gateway. Hopefully that makes sense. Let me give you an example. And we kind of just did this a second ago in the last one, but we're going to do it again just for fun. If I check my ARP table, and ARP tables are great because ARP tables just show the marriage between a source and destination, a destination's IP address and MAC address that my machine has learned. I'm going to go ahead and clear it. I'm going to do an ARP space -D. And that's going to not work because I didn't open this with administrator rights. So we are going to come back and I'm going to show you how to do that. And we're going to say yes to that. And let's do it again. ARP space -D. We're going to clear that out. And let's type it in again. ARP space -A. Show me the ARP table. Not a lot going on here right now. Now let's ping 192.168.1.72. Ping 192.168.1.72. It responds back. Fantastic. If I do an ARP space -A right now, you'll see that 192.168.1.72 has been added into my table. Fantastic. Now, if I want to ping 8.8.8.8, now I know 1.254 is already in there, but you're going to see that nothing else is going to get added because 192.168.1.254 is the address of my default gateway. Let's just do an IP config, and I'll show you what I mean. So if I take a look at my device, and I see I'm on the wires. I got two networks going right now. Let's go back to this one. If I take a look here, my IP address is 192.168.1.130. Anything that's local, I'm going to ARP and say, who is that actual device? Anything that's remote, I'm just going to say, who is 192.168.1.254? Who is my default gateway? And my default gateway is going to tell me how to get off of my network because it's going to send it to my router. I'm not going to have to worry about it anymore. It's just like taking something to the mailbox. I put it in the post office's hands. They figure out where it needs to go to. So this is kind of the same thing. Do I know the MAC address of 8.8.8.8? I don't. Do I need to know it? I don't. I just need to know the MAC address of my default gateway. If we could follow this path, this traffic, it will leave my device and go to my router here and then go out into the internet and find its way to 8.8.8.8. So that's what they're getting into in this particular set of slides, is that when we have a local traffic, devices that just have to cross a switch, we're going to attempt to find the MAC address of that device. Now, for information that we want to send to another network, we're going to attempt to find the MAC address of the default gateway value of our network, the default gateway. Without a default gateway, we cannot communicate with devices that are outside of our network because we don't know how to get our information to our router to send it towards the destination. And I don't know if that made sense or not, but hopefully we're going to do a whole section on ARP next.